JavaScript is a lightweight, interpreted, or just-in-time compiled programming language with first-class functions. While it is most well known as the scripting language for web pages, many non-browser environments also use it, such as Node.js, Apache Couch and Adobe Acrobat. JavaScript is a prototype-based, multi-paradigm, single-threaded, dynamic language supporting object-oriented, imperative, and declarative functional programming styles. This video is dedicated to the JavaScript language itself and not the parts that are specific to web pages or other host environments. For information about API specifics to web pages, please see Web APIs and DOM. The standards for JavaScript are the ECMAScript Language Specification, ECMA 262, and the ECMAScript Internationalization API Specification, ECMA 402. The JavaScript documentation throughout MDN is based on the latest draft versions of ECMA 262 and ECMA 402. And in cases where some proposals for new ECMAScript features have already been implemented in browsers, documentation and examples in MDN articles may use some of those new features. Do not confuse JavaScript with the Java programming language. Both Java and JavaScript are trademarks or registered trademarks of Oracle in the US and other countries. However, the two programming languages have very different syntax, semantics, and use. For complete beginners, head over to our learning area JavaScript topic if you want to learn JavaScript but have no previous experience with JavaScript or programming. The complete modules available there are as follows. JavaScript First Steps answers some fundamental questions such as what is JavaScript, what does it look like, and what can it do, along with discussing key JavaScript features such as variables, strings, numbers, and arrays. JavaScript Building Blocks continues our coverage of JavaScript's key fundamental features, turning our attention to commonly encountered types of code blocks such as conditional statements, loops, functions, and events. Introducing JavaScript objects. The object-oriented nature of JavaScript is important to understand if you want to go further with your knowledge of the language and write more efficient code. Therefore, we've provided this module to help you. Asynchronous JavaScript discusses asynchronous JavaScript, why it is important, and how it can be used to effectively handle potential blocking operations such as fetching resources from a server. Client-side Web APIs explores what APIs are and how to use some of the most common APIs you'll come across often in your development work. For intermediate level, understanding client-side JavaScript frameworks. JavaScript frameworks are an essential part of modern front-end web development, providing developers with proven tools for building scalable, interactive web applications. This module gives you some fundamental background knowledge about how client-side frameworks work and how they fit into your toolset before moving on to tutorial series covering some of today's most popular ones. A reintroduction to JavaScript and overview for those who think they know about JavaScript. JavaScript Data Structures Overview of available data structures in JavaScript. Equality comparisons and sameness. JavaScript provides three different value comparison operations: strict equality using ===, loose equality using ==, and the object.is method. Closures. A closure is the combination of a function and the lexical environment within which that function was declared. Advanced level. Inheritance and the prototype chain. Explanation of the widely misunderstood and underestimated prototype-based inheritance. Strict mode. Strict mode defines that you cannot use any variable before initializing it. It is a restricted variant of ECMAScript 5 for faster performance and easier debugging. JavaScript typed arrays. JavaScript typed arrays provide a mechanism for accessing raw binary data. Memory management. Memory lifecycle and garbage collection in JavaScript. Concurrency model and event loop. JavaScript has a concurrency model based on an event loop. JavaScript is one of the most popular modern web technologies. As your JavaScript skills grow, your websites will enter a new dimension of power and creativity. However, getting comfortable with JavaScript is more challenging than getting comfortable with HTML and CSS. You may have to start small and progress gradually. To begin, let's examine how to add JavaScript to your page for creating a Hello World example. First, go to your test site and create a new folder named Scripts. Within the Scripts folder, create a new file called main.js and save it. Now, in your index.html file, enter this code on a new line just before the closing body tag. This is doing the same job as the link element for CSS. It applies the JavaScript to the page so it can have an effect on the HTML, along with the CSS and anything else on the page. Add this code to the main.js file. What happened? The heading text changed to Hello World using JavaScript. You did this by using a function called querySelector to grab a reference to your heading and then store it in a variable called myHeading. This is similar to what we did using CSS selectors. When you want to do something to an element, you need to select it first. Following that, the code set the value of the myHeading variable's text content property, which represents the content of the heading, to Hello World. This video discusses JavaScript's basic grammar, variable declarations, data types and literals. JavaScript borrows most of its syntax from Java, C, and C++, but it has also been influenced by awk, Perl, and Python. JavaScript is case-sensitive and uses the Unicode character set. For example, the word fra, which means early in German, could be used as a variable name. But the variable fra is not the same as fra because JavaScript is case-sensitive. In JavaScript, instructions are called statements and are separated by semicolons. Colon is not necessary after a statement if it is written on its own line. But if more than one statement on a line is desired, then they must be separated by semicolons. It is considered best practice, however, to always write a semicolon after a statement, even when it is not strictly needed. This practice reduces the chances of bugs getting into the code. The source text of JavaScript gets scanned from left to right and is converted into a sequence of input elements which are tokens, control characters, line terminators, comments, or whitespace. The syntax of comments is the same as in C++ and in many other languages. Comments behave like whitespace and are discarded during script execution. JavaScript has three kinds of variable declarations. Var declares a variable, optionally initializing it to a value. Let declares a block-scoped, local variable, optionally initializing it to a value. Const declares a block-scoped, read-only named constant. You use variables as symbolic names for values in your application. The names of variables, called identifiers, conform to certain rules. A JavaScript identifier must start with a letter, underscore, or $sign, $. Subsequent characters can also be digits, 0, 9. Because JavaScript is case-sensitive, letters include the characters A through Z, uppercase, as well as A through Z, lowercase. You can use most of ISO 88591 or Unicode letters such as A and U in identifiers. You can declare a variable in two ways, with the keyword var. For example, var x equals 42. This syntax can be used to declare both local and global variables, depending on the execution context. With the keyword const or let. For example, let y equals 13. This syntax can be used to declare a block scope local variable. You can declare variables to unpack values from object literals using the destructuring assignment syntax. For example, let bar equals foo. This will create a variable named bar and assign to it a value corresponding to the key of the same name from our object foo. You can also assign a value to a variable, for example, x equals 42. This form creates an undeclared global variable. It also generates a strict JavaScript warning. Undeclared global variables can often lead to unexpected behavior. Thus, it is discouraged to use undeclared global variables. Variable scope. When you declare a variable outside of any function, it is called a global variable because it is available to any other code in the current document. When you declare a variable within a function, it is called a local variable because it is available only within that function. JavaScript before ECMAScript 2015 does not have block statement scope. Rather, a variable declared within a block is local to the function or global scope that the block resides within. For example, the following code will log 5 because the scope of X is the global context or the function context if the code is part of a function. The scope of X is not limited to the immediate if statement block. Variable hoisting. Another unusual thing about variables in JavaScript is that you can refer to a variable declared later without getting an exception. This concept is known as hoisting. Variables in JavaScript are, in a sense, hoisted or lifted to the top of the function or statement. However, variables that are hoisted return a value of undefined. So even if you declare and initialize after you use or refer to this variable, it still returns undefined. Because of hoisting, all var statements in a function should be placed as near to the top of the function as possible. This best practice increases the clarity of the code. In ECMAScript 2015, let and const are hoisted but not initialized. Referencing the variable in the block before the variable declaration results in a reference error because the variable is in a temporal dead zone from the start of the block until the declaration is processed. Constants. You can create a read-only, named constant with the const keyword. The syntax of a constant identifier is the same as any variable identifier. It must start with a letter, underscore, or $sign, and can contain alphabetic, numeric, or underscore characters. A constant cannot change value through assignment or be redeclared while the script is running. It must be initialized to a value. The scope rules for constants are the same as those for let block scope variables. If the const keyword is omitted, the identifier is assumed to represent a variable. You cannot declare a constant with the same name as a function or variable in the same scope. JavaScript is a dynamically typed language. This means you don't have to specify the data type of a variable when you declare it. It also means that data types are automatically converted as needed during script execution. So, for example, you could define a variable as follows. This variable contains integer value. Set this value inside an console log function. And open browser debugging option. Check this console. Absolutely, this value is integer. And later, you could assign the same variable a string value, for example. Open browser and check this value are string. Because JavaScript is dynamically typed, this assignment does not cause an error message. In expressions involving numeric and string values with the plus operator, JavaScript converts numeric values to strings. For example, consider the following statements. Look at this output. Their answer is always string value. Because string plus integer equals string. With all other operators, JavaScript does not convert numeric values to strings. For example, because integer string plus integer equals integer value. Now we converting strings to numbers. In the case that a value representing a number is in memory as a string, there are methods for conversion. In the case that a value representing a number is in memory as a string, there are methods for conversion. The parseInt function converts its first argument to a string, parses that string, then returns an integer or nan. The global nan property is a value representing not a number. The following examples all return nan. If not nan, the return value will be the integer that is the first argument taken as a number in the specified radix. For example, a radix of 10 converts from a decimal number, 8 converts from octal, 16 from hexadecimal, and so on. For radices above 10, letters of the English alphabet indicate numerals greater than 9. For example, for hexadecimal numbers, base 16, A through F are used. If parseInt encounters a character that is not a numeral in the specified radix, it ignores it and all succeeding characters and returns the integer value parsed up to that point. ParseInt truncates numbers to integer values. Leading and trailing spaces are allowed. The following examples all return 15. The following examples all return 4. ParseInt doesn't work with numeric separators. Example is the parseFloat function parses an argument, converting it to a string first if needed, and returns a floating point number. Literals represent values in JavaScript. These are fixed values, not variables, that you literally provide in your script. This section describes the following types of literals. An array literal is a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. When you create an array using an array literal, it is initialized with the specified values as its elements, and its length is set to the number of arguments specified. The following example creates the coffees array with 3 elements and a length of 3. If an array is created using a literal in a top-level script, JavaScript interprets the array each time it evaluates the expression containing the array literal. In addition, a literal used in a function is created each time the function is called. You do not have to specify all elements in an array literal. If you put 2 commas in a row, the array fills in the value undefined for the unspecified elements. The following example creates the fish array. This array has 2 elements with values and 1 empty element. Fish 0 is lion. Fish 1 is undefined. Fish 2 is angel. If you include a trailing comma at the end of the list of elements, the comma is ignored. In the following example, the length of the array is 3. Next JavaScript array element tutorial I will describe all array formation. The value passed as the first parameter is converted to a Boolean value, if necessary. If the value is omitted or is 0, -0, null, false, nan, undefined, or the empty string, the object has an initial value of false. All other values, including any object, an empty array, or the string false, create an object with an initial value of true. Do not confuse the primitive Boolean values true and false with the true and false values of the Boolean object. Any object of which the value is not undefined or null, including a Boolean object whose value is false, evaluates to true when passed to a conditional statement. For example, the condition in the following if statement evaluates to true. JavaScript numeric literals include integer literals in different bases as well as floating point literals in base 10. Note that the language specification requires numeric literals to be unsigned. Nevertheless, code fragments like -123.4 are fine, being interpreted as a unary operator applied to the numeric literal 123.4. A floating point literal can have the following parts: an unsigned decimal integer, a decimal point, dot, a fraction, another decimal number, an exponent. The exponent part is an e, or e followed by an integer, which can be signed, preceded by plus or. A floating point literal must have at least 1 digit, and either a decimal point or e. An object literal is a list of 0 or more pairs of property names and associated values of an object, enclosed in curly braces. A regex literal is a pattern enclosed between slashes. The following is an example of a regex literal, which is defined in detail later. Template literals are also available. Template literals are enclosed by the backtick character instead of double or single quotes. Template literals provide syntactic sugar for constructing strings. This is similar to string interpolation features in Perl, Python, and more. Tag templates are a compact syntax for specifying a template literal along with a call to a tag function for parsing it. The name of the template tag function precedes the template literal, as in the following example, where the template tag function is named myTag. In addition to ordinary characters, you can also include special characters in strings, as shown in the following example. The following table lists the special characters that you can use in JavaScript strings. JavaScript supports a compact set of statements, specifically control flow statements, that you can use to incorporate a great deal of interactivity in your application. This video provides an overview of these statements. A conditional statement is a set of commands that executes if a specified condition is true. JavaScript supports two conditional statements, if, else and switch. Use the if statement to execute a statement if a logical condition is true. Use the optional else clause to execute a statement if the condition is false. An if statement looks like this. Here, the condition can be any expression that evaluates to true or false. If condition evaluates to true, statement 1 is executed. Otherwise, statement 2 is executed. Statement 1 and statement 2 can be any statement, including further nested if statements. You can also compound the statements using else, if to have multiple conditions tested in sequence, as follows. In the case of multiple conditions, only the first logical condition which evaluates to true will be executed. To execute multiple statements, group them within a block statement. In general, it's good practice to always use block statements, especially when nesting if statements. It's unwise to use simple assignments in a conditional expression because the assignment can be confused with equality when glancing over the code. For example, do not write code like this. If you need to use an assignment in a conditional expression, a common practice is to put additional parentheses around the assignment, like this. In the following example, the function checkData returns true if the number of characters in a text object is 3. Otherwise, it displays an alert and returns false. The switch statement allows a program to evaluate an expression and attempt to match the expression's value to a case label. If a match is found, the program executes the associated statement. A switch statement looks like this. JavaScript evaluates the above switch statement as follows. The program first looks for a case clause with a label matching the value of expression and then transfers control to that clause, executing the associated statements. If no matching label is found, the program looks for the optional default clause. If a default clause is found, the program transfers control to that clause, executing the associated statements. If no default clause is found, the program resumes execution at the statement following the end of switch. By convention, the default clause is written as the last clause, but it does not need to be so. The optional break statement associated with each case clause ensures that the program breaks out of switch once the matched statement is executed and then continues execution at the statement following switch. If break is omitted, the program continues execution inside the switch statement and will evaluate the next case, and so on. In the following example, if fruit type evaluates to bananas, the program matches the value with case bananas and executes the associated statement. When break is encountered, the program exits the switch and continues execution from the statement following switch. If break were omitted, the statement for case cherries would also be executed. Use the throw statement to throw an exception. A throw statement specifies the value to be thrown. You may throw any expression, not just expressions of a specific type. The following code throws several exceptions of varying types. Try, catch statement. The try, catch statement marks a block of statements to try and specifies one or more responses should an exception be thrown. If an exception is thrown, the try, catch statement catches it. The try, catch statement consists of a try block, which contains one or more statements, and a catch block, containing statements that specify what to do if an exception is thrown in the try block. In other words, you want the try block to succeed, but if it does not, you want control to pass to the catch block. If any statement within the try block, or in a function called from within the try block, throws an exception, control immediately shifts to the catch block. If no exception is thrown in the try block, the catch block is skipped. The finally block executes after the try and catch blocks execute, but before the statements following the try, catch statement. The following example uses a try, catch statement. The example calls a function that retrieves a month name from an array based on the value passed to the function. If the value does not correspond to a month number, 112, an exception is thrown with the value invalidmonthno, and the statements in the catch block set the month name variable to unknown. The catch blocks. You can use a catch block to handle all exceptions that may be generated in the try block. The catch block specifies an identifier, catch it in the preceding syntax, that holds the value specified by the throw statement. You can use this identifier to get information about the exception that was thrown. JavaScript creates this identifier when the catch block is entered. The identifier lasts only for the duration of the catch block. Once the catch block finishes executing, the identifier no longer exists. For example, the following code throws an exception. When the exception occurs, control transfers to the catch block. The finally block. The finally block contains statements to be executed after the try and catch blocks execute. Additionally, the finally block executes before the code that follows the try, catch, finally statement. It is also important to note that the finally block will execute whether or not an exception is thrown. If an exception is thrown, however, the statements in the finally block execute, even if no catch block handles the exception that was thrown. You can use the finally block to make your script fail gracefully when an exception occurs. For example, you may need to release a resource that your script has tied up. The following example opens a file and then executes statements that use the file. Server-side JavaScript allows you to access files. If an exception is thrown while the file is open, the finally block closes the file before the script fails. Using finally here ensures that the file is never left open, even if an error occurs. If the finally block returns a value, this value becomes the return value of the entire try, catch, finally production, regardless of any return statements in the try and catch blocks. Overriding of return values by the finally block also applies to exceptions thrown or rethrown inside of the catch block. Utilizing error objects. Depending on the type of error, you may be able to use the name and message properties to get a more refined message. The name property provides the general class of error, such as DOM exception or error, while message generally provides a more succinct message than one would get by converting the error object to a string. If you are throwing your own exceptions, in order to take advantage of these properties, such as if your catch block doesn't discriminate between your own exceptions and system ones, you can use the error constructor. Loops offer a quick and easy way to do something repeatedly. This chapter of the JavaScript guide introduces the different iteration statements available to JavaScript. You can think of a loop as a computerized version of the game where you tell someone to take X steps in one direction, then Y steps in another. For example, the idea "go 5 steps to the east" could be expressed this way as a loop. There are many different kinds of loops, but they all essentially do the same thing. They repeat an action some number of times. Note that it's possible that number could be 0. The various loop mechanisms offer different ways to determine the start and end points of the loop. There are various situations that are more easily served by one type of loop over the others. For statement. A for loop repeats until a specified condition evaluates to false. The JavaScript for loop is similar to the Java and C for loop. A for statement looks as follows. When a for loop executes, the following occurs. The initializing expression initial expression, if any, is executed. This expression usually initializes one or more loop counters, but the syntax allows an expression of any degree of complexity. This expression can also declare variables. The condition expression is evaluated. If the value of condition expression is true, the loop statements execute. If the value of condition is false, the for loop terminates. If the condition expression is omitted entirely, the condition is assumed to be true. The statement executes. To execute multiple statements, use a block statement to group those statements. If present, the update expression increment expression is executed. Control returns to step 2. While statement. A while statement executes its statements as long as a specified condition evaluates to true. A while statement looks as follows. If the condition becomes false, statement within the loop stops executing and control passes to the statement following the loop. The condition test occurs before statement in the loop is executed. If the condition returns true, statement is executed and the condition is tested again. If the condition returns false, execution stops and control is passed to the statement following while. To execute multiple statements, use a block statement to group those statements. The following while loop iterates as long as n is less than 3. With each iteration, the loop increments n and adds that value to x. Therefore, x and n take on the following values. After the first pass, n equals 1 and x equals 1 after the second pass. N equals 2 and x equals 3 after the third pass. N equals 3 and x equals 6 after completing the third pass, the condition n3 is no longer true, so the loop terminates. Do-while statement. The do-while statement repeats until a specified condition evaluates to false. A do-while statement looks as follows. Statement is always executed once before the condition is checked. To execute multiple statements, use a block statement to group those statements. If condition is true, the statement executes again. At the end of every execution, the condition is checked. When the condition is false, execution stops and control passes to the statement following do-while. In the following example, the do loop iterates at least once and reiterates until I is no longer less than 5. Continue statement. The continue statement can be used to restart a while, do while, for, or label statement. When you use continue without a label, it terminates the current iteration of the innermost enclosing while, do while, or for statement and continues execution of the loop with the next iteration. In contrast to the break statement, continue does not terminate the execution of the loop entirely. In a while loop, it jumps back to the condition. In a for loop, it jumps to the increment expression. When you use continue with a label, it applies to the looping statement identified with that label. The syntax of the continue statement looks like the following. First example. The following example shows a while loop with a continue statement that executes when the value of I is 3. Thus, n takes on the values 1, 3, 7, and 12. Second example. A statement labeled checkinj contains a statement labeled checked. If continue is encountered, the program terminates the current iteration of checked and begins the next iteration. Each time continue is encountered, checked reiterates until its condition returns false. When false is returned, the remainder of the checkinj statement is completed and checkinj reiterates until its condition returns false. When false is returned, the program continues at the statement following checkinj. If continue had a label of checkinj, the program would continue at the top of the checkinj statement. For, in. A for, in loop only iterates over enumerable, non-symbol properties. Objects created from built-in constructors like array and object have inherited non-enumerable properties from object prototype and stringed prototype, such as strings indexif method or objects toString method. The loop will iterate over all enumerable properties of the object itself and those the object inherits from its prototype chain. Properties of nearer prototypes take precedence over those of prototypes further away from the object in its prototype chain. Examples 1. Using for, in. The for in loop below iterates over all of the object's enumerable, non-symbol properties and logs a string of the property names and their values. The for of statement creates a loop iterating over iterable objects, including built-in string, array, array-like objects. Arguments are not a list, typed array, map, set, and user-defined iterables. It invokes a custom iteration hook with statements to be executed for the value of each distinct property of the object. Look at this example. Functions are one of the fundamental building blocks in JavaScript. A function in JavaScript is similar to a procedure, a set of statements that performs a task or calculates a value, but for a procedure to qualify as a function, it should take some input and return an output where there is some obvious relationship between the input and the output. To use a function, you must define it somewhere in the scope from which you wish to call it. A function definition, also called a function declaration or function statement, consists of the function keyword followed by the name of the function, a list of parameters to the function, enclosed in parentheses and separated by commas. The JavaScript statements that define the function, enclosed in curly brackets. For example, the following code defines a simple function named square. The function square takes one parameter, called number. The function consists of one statement that says to return the parameter of the function, that is, number, multiplied by itself. The statement return specifies the value returned by the function. Primitive parameters, such as a number, are passed to functions by value. The value is passed to the function, but if the function changes the value of the parameter, this change is not reflected globally or in the calling function. If you pass an object, i.e., a non-primitive value, such as array or a user-defined object, as a parameter and the function changes the object's properties, that change is visible outside the function, as shown in the following example. Function expressions. While the function declaration above is syntactically a statement, functions can also be created by a function expression. Such a function can be anonymous, it does not have to have a name. For example, the function square could have been defined as. However, a name can be provided with a function expression. Providing a name allows the function to refer to itself and also makes it easier to identify the function in a debugger's stack traces. Function expressions are convenient when passing a function as an argument to another function. The following example shows a map function that should receive a function as first argument and an array as second argument. In the following code, the function receives a function defined by a function expression and executes it for every element of the array received as a second argument. Function scope. Variables defined inside a function cannot be accessed from anywhere outside the function because the variable is defined only in the scope of the function. However, a function can access all variables and functions defined inside the scope in which it is defined. In other words, a function defined in the global scope can access all variables defined in the global scope. A function defined inside another function can also access all variables defined in its parent function and any other variables to which the parent function has access. Nested functions and closures. You may nest a function within another function. The nested, inner function is private to its containing, outer function. It also forms a closure. A closure is an expression, most commonly, a function, that can have free variables together with an environment that binds those variables, that closes the expression. Since a nested function is a closure, this means that a nested function can inherit the arguments and variables of its containing function. In other words, the inner function contains the scope of the outer function. To summarize, the inner function can be accessed only from statements in the outer function. The inner function forms a closure. The inner function can use the arguments and variables of the outer function, while the outer function cannot use the arguments and variables of the inner function. The following example shows nested functions. Since the inner function forms a closure, you can call the outer function and specify arguments for both the outer and inner function. Closures. Closures are one of the most powerful features of JavaScript. JavaScript allows for the nesting of functions and grants the inner function full access to all the variables and functions defined inside the outer function and all other variables and functions that the outer function has access to. However, the outer function does not have access to the variables and functions defined inside the inner function. This provides a sort of encapsulation for the variables of the inner function. Also, since the inner function has access to the scope of the outer function, the variables and functions defined in the outer function will live longer than the duration of the outer function execution if the inner function manages to survive beyond the life of the outer function. A closure is created when the inner function is somehow made available to any scope outside the outer function. It can be much more complex than the code above. An object containing methods for manipulating the inner variables of the outer function can be returned. In the code above, the name variable of the outer function is accessible to the inner functions, and there is no other way to access the inner variables except through the inner functions. The inner variables of the inner functions act as safe stores for the outer arguments and variables. They hold persistent and encapsulated data for the inner functions to work with. The functions do not even have to be assigned to a variable or have a name.